Thank you, Oliver, for the introduction. I'm going to use a little bit of a different, I've seen a lot of nice academic research. And of course, I'm working as an academic too, but as I am working as a professional engineer, I will try to give a perspective a little bit of a different direction and a bit of feedback, what I encounter in daily practice. I know we try to be early adopters with the office, so that means that we try to really build these things. And I think much of you would like to have your solutions out there in the world. So what we try as structural engineers is try to do that and accompany people with their projects. So it's a lot of different projects, to be honest, so I couldn't focus on just one. But I would say it's to give a little bit of food for discussion with the different people here in the room, and what opportunities and complexities that we encounter mostly with these projects. So we work with a lot of different materials, whether it be timber, glass, or other stuff, and 3D concrete printing. It's mostly concrete printing, of course. We got involved, let's say, 10 years ago. So I'm going to focus on 4 parts: digital tools, the freedom of form, structural design for 3D printing, and on-site or prefabrication. So what happens is we're always a bit lucky to encounter these very crazy people, like most of you in the room here, and to do some collaboration. So all of these things are, of course, in collaboration, and we're learning each time. So this is with the people from Delft, and we developed ourselves back in the days this parametric program called Caramba, and one of my colleagues was working with people from Delft also to find a tool where we can in real time see the structural performance of what is being printed. So taking the data, learning by that data, and constantly improving if the buckling behavior would be okay. So this is basically what the future for us could hold, that by using these digital tools, that on the fly we could actually see the structural performance of these things. So for me, it's also, as a trained architect, also my hope would be that in the end, the architect gets back the power to do the architecture himself. So you sit in the office and you print immediately from a distance. And there's an automatic update also, whether it works structurally or not. So all the workflow on one platform, the digital platform. And this rapid prototyping, of course, is a fantastic item where this collaboration could exist. And so we try to develop the tools throughout we include it in our daily basis. And I have to admit, this is a student's project in Versailles. We had the COVID, so I thought no better way to explain how digital things work. So we were teaching them how to use a platform, also the slicers. It's together with Sika. And at the end, basically what happened, my 180 students all made a singular design, bespoke, and Sika delivered it automatically to the school in Versailles, which is a bit weird because it's all in stones. It's in front of the Château de Versailles. So to have these 3D printed columns is a bit weird, but it shows also how it works. They were all working from home in the COVID time, and all of a sudden they have the full control of the full design, which is a promise for me actually for architecture, I hope. For us, of course, as engineers, what I'm more interested in is, of course, by topological optimization, that we could optimize the carbon footprint. And I think there, by doing competitions, such as this one for a 40-meter span bridge, we needed to come up with the shape. And this is, again, it's with our digital tools. But what here the hope or the opportunity for me was present, that we tried to optimize as much the shape of the bridge by the 3D printing. So the 3D printed concrete would be structural and would be combined with BSC. BSC is a high-yield concrete, 120 MPa, if I'm not mistaken. So they would work together. It would be singular pieces that are kept together with the pre-stressed cable. So it's a hybrid. It's not a pure solution of 3D printed concrete. But what was very interesting, the state prescribed a process where a university, together with architects, together with the contractor, together with a 3D print company, together with engineers, would set up partially a research program, partially a real project. And this was very interesting. So we're still trying from that experience, because we lost the competition and the thing got never built, of course. But from that one, we actually went on from that little experience. And this is sometimes the thing also, you have to keep on doing it. So the competition was in 2016. It was supposed to be for the Olympics. And basically now, at the moment, we are printing in Thailand this bridge with another contractor. And we use the same tools and the same ideas. So we optimize topologically the whole project. So this is a bit research. So what we use is the structural force flow in the bridge. And we try to optimize the 3D processes. So for us, it bears that quality of the freedom of form. Somebody already showed that image on the right from Pierluigi Nervi. And why I come to these days also is to get inspiration and then to try to really do it for reality. So this is a research done at the KET, so at a university in Berlin, with Professor Gengnagel, together with Hen and Sika. And then I found a person crazy enough to try to construct it. So at the moment, we're busy to do this in the north of France. So it's in Valenciennes. And some of the researchers in Berlin are actually helping us. But this is also the advantage to not have these boundaries between the industry and between the academia, of course. So you can just suggest, basically. But it's again to optimize the slabs, the force flow, and to really 3D print these slabs. So it means structural design, and we have tried it much before. Basically what happens, since this was a project 10 years ago, but we got kicked out because we were too crazy, apparently. So no reinforcement, so no fibers. It was also with X3, and then the Prüfingenieur, the controlling engineer, he said we cannot get an insurance for that. And this is where the whole thing stops, basically. And why I'm sometimes out there is to make sure I put my signature and that we don't take an insurance and it all goes onto my name. And this is the beauty. Sometimes it works in Switzerland. It doesn't work in France. It doesn't work in Germany. It doesn't work in Belgium. Well, in Belgium it does. And in Thailand it also does. So I just sign and it's fine. But here, so you have to find reasons and ways how to convince people. And this is really, so we need structural design for 3D printing. So for the buckling, instead of putting reinforcement, I just went with geometry. So if you make indentures, you actually play with the form and geometry to make it structurally sound. And I think this is also our task as engineers. So from that project, learning again, we are now building, well, the building is actually almost ready. It's a 3-story building, 3D printed in the north of France with Antoine Mott. I don't think he's here today, but check him out. He's selling robots. So please, he's a very fine guy and he's selling them worldwide. And he's printing himself his own Cité des Savoirs. And we are on the fly learning and there's no insurance. So I made an agreement with him. He's printing up to 5,000 square meters in total. And we do it on our own. It's his site, so he takes responsibility and we take responsibility for ourselves. It's nice, actually. And from these, I have another example, and I think it's each time with a new client, we try it out. And I think this is the problem what we faced. We have to prototype a lot ourselves, and we don't have the budget for it. Who's paying for it? You have the same at university level. I have the same in the private. So this was for an industrial hall, and I saw already a little shell in another presentation with the fibers before from Leo, I think. So it's a good idea. I think we should try it out. Because this is the one here we started testing. The client gave up after a while. But each time you construct a bit, you get more knowledge. And you have to get it out, built, I think. And so we need to prototype. Because usually nobody, the Prüfingenieur or the controlling engineer, will not sign off on the project if there's not enough testing being done, but we don't have time for that. And every building is an sich already a prototype. So this is another tryout that we do. I will not go into detail. So this is one that we would like to test, basically, but without fibers. And so the last part I wanted to dedicate is to what we often get as a question: do we print on-site or off-site? Honestly speaking, I don't really have much of an opinion, but it's quite complex to do it off-site. You have much more control over the quality, but you have the reverse, that how do you put the pieces together? So often there's a lot of metal pieces included. You have the structural glues that you can use, but they are not okay for the fire. And on the right, for example, what is this maybe the job of the future? So this is a 3D printed house that we were doing. So 3 stories. And there's only 2 guys sitting there and they watch the screen of a computer. So the robot is busy, and once in a while they have to turn the robot a bit around. And I think for me, it has a lot to do with what will we want to do with the workers on site. So how do we, the quality of work, and maybe the quality also of the execution. I think that's a big question that we need to ask ourselves anyway. I think labor is going to be too expensive, or should be already much more expensive. And I think there's a quality and a possibility for us to really gain in that part of our dirty business of building buildings. So, but you see how manual it still becomes. They are putting rebars in it, so it's a triple layered wall filled up with concrete. And I'm not very much a fan of it. I would like to get out much more of the concrete. But still, on-site printing has a lot of problems, a lot of qualities, especially with the temperature, the drying, the aging. So, and there's a lot of cracks also that you need to be careful with. The offsite has all these things that you have with the steel elements, of course. So I'm happy to discuss even afterwards. I think it's just, we're learning all the time with all these projects. And we're lucky also to do them worldwide. So each time it's with a different contractor or with a different person. And I hope anytime soon we can see some more innovative projects also. That's it.
Thank you very much, Klaas de Rycke. And the floor is open for questions. Yes.
Hello, thank you for your speech. Do you have any experience with earth-based materials?
Sorry, what?
Do you have any experience with earth-based materials?
Yes, and also even with the timber, by the way, it's we also tried it already, and the earth-based. So this one here on the left, what is happening, because Antoine Mott, he makes his own robots, and the cement, he's trying out the different providers, of course, and he's trying to get the least expensive material. So it's Sika, Lafarge, whatever. And since he got really upset with them, he's now making his own concrete. And he also wants to reduce the cement factor, of course, in it. And that's where he's trying with argile, with clay, also to... So the idea is that they have a formula at the moment that would reduce already of, I think, 40% the carbon footprint. It's not perfect. We have tried it with regular clay also, and even at the university with students and all this. But I don't see it yet as a... Well, it's a possibility, but I haven't tried really in a building. So that's our next step. Yes.
And do you have information about the mechanic, like the strength of that wall or something?
For this one?
Yeah.
Yes, I mean, we get the data from actually, because this guy is producing himself the things, and he also invented a little machine that is doing, because normally for structural engineers, we need the blocks have a standardized size to be tested, which with 3D concrete doesn't exist. So he has a little machine himself that, let's say, every 5 minutes takes a sample, it gives it in. And by having so many samples, you can see the quality and the difference in quality compared to the reality. So it's a kind of data knowledge that he has. And he sells the machine now also. So it's only these little samples, it goes much faster. And he gives us the strength also. And actually with this one, it was quite easy because it's actually Sika that gave a minimal value, which is no, I shouldn't use that word, but actually they can go up much higher because they only give you 30 MPa or something, or 25. You could go up easily to 80. So, and with Lafarge, it's even the same. So they have the very high yield, but actually they give you low value to be okay with the regulations.
Thank you.
One more question here.
Thank you for a great presentation. What I was wondering is, is the Caramba system integrated inside the 3D printing logic, or the other way around? Like if you can feed the pathways of your printer based on reactions of material properties when it is 3D printed, and if this information is integrated inside a Caramba system.
Because that's exactly what they tried to set up. I have to admit, I didn't follow it afterwards because it's really Clemens that is working on that in our office. And ideally, we would use it in regular projects. But that's the thing. They are implementing it that you can then change the thickness, fastness of the thing, of course. Yeah.
Thank you for your presentation. I have a question regarding like the offsite 3D printing. Do you have like a preferred modular shape for like doing it and bring it to the site? The second question is about to how extent do you think this process is like recyclable or reusable? So if you like deconstruct it.
For the offsite, right?
Yeah.
I have to admit, the experience we had was not so lucky, to be honest. I think the pieces are not so big, and in the end, the only restraint that you have is really the truck. And then the little crane, and actually the pieces are not so big, and whatever, it becomes a volume. So we optimize the shape for structural reasons, but then you start to cut it up in pieces, and the pieces are not very big. And to reuse the cement, it's like every concrete at the moment. So it's true, that's not much more developed than that. So carbon footprint, we have to work on it, I guess. Thank you.
Thank you, Klaas.